So, for those of you who don't know about Minted is a design marketplace that crowdsources all of its art and design through a community of independent artists. And the public votes on these designs, tells us what to sell, and then they're manufactured in the form of stationery, art prints, and home decor products. And so, about a year ago, we had the opportunity to work on a number of very front-end heavy projects. And this is an example. We had a new header redesign and navigation redesign, as well as a new homepage. And so we kind of started thinking, like, this is a good opportunity to invest in our front end and try to clean up some of the technical debt we've been facing over the years. And so our legacy front end was kind of a combination of a hodgepodge of various different things. And we had multiple PHP apps, we had Python web app, we had coded jQuery, Backbone, sort of a variety of build tools. And this is just the kind of evolution of a small startup and different teams making different technology choices over the years. And so some of the main problems with this, we had a lot of duplicated code through the client and server. So we were writing the same HTML rendering code, both in either Mako or Python, and then also in JavaScript. There's a lot of duplicated UI across teams, so one team might build a mobile dialog or a drop-down widget, and then a different team might build something completely different. So we didn't have a lot of reusability and a way to test our UI components. And then a number of our web apps had really complex event flows, and so we were spending a lot of time debugging issues related to application state. And really, there was really no separation between our kind of API data fetching layer and our HTML rendering layer. And so this was hard to test. And so here's an example of our header from 2 years ago, and this is a global component, so because we had multiple PHP web apps and a Python app, we were having to update as many as like 4 files just to like make one small tiny change to the top of the page. And then here you go again. There's multiple different drop downs. One might be in Mako, one might be in Backbone. And so there's a lot of visual consistency, which is for a design-based company. Really hurt our brand. And I'm sure you've seen code like this before, so there's a little snippet of some jQuery that's embedded inside of one of the server rendered templates. And this is impossible to test without some kind of full end-to-end kind of browser-based testing. And then on top of that, there's some web apps we had that had really, really complex event flows. And so it's impossible to kind of build a mental model around like what's going on. And so this trivial bugs would actually take a lot of development time to reproduce and debug. So no front-end vision, right? We knew we needed to clean this up, and we had a good opportunity to do it.
Hey everyone, I'm Andrew. I'm engineer on the econ team. So we had this situation, right? There's a number of years of organic growth. It happens at any large company. You have development that occurs across different teams and throughout the organization, and you need to rein it in, right? At some point, it becomes more expensive to maintain than it is to simply start steering the ship into a new direction. That's really the challenge. Like, we wanted to have a new infrastructure, but we couldn't just like sit and refactor it all, right? That's impossible. So we had a few goals. We knew off the bat that we wanted to be able to develop, debug, and test easily. Like, this is obviously priority number one. And really, the tricky part is not defining what your ideal state is. The tricky part is how you get there, and how can you deliver value to customers incrementally? How can you make the case for a financially feasible way of actually making your architecture better, and making the customer experience better ultimately. So we had to be able to make these improvements incrementally. We couldn't just sit and refactor large swaths of things just because it's better technologically. As Sean demonstrated, like we started to get a little bit of, we got local optimizations across different teams, and this results in fragmentation. So we definitely wanted to have reusable, consistent components that could be basically just be the same across the entire site. So the other thing that was really a big requirement for our front-end vision was being able to do server-side rendering, get right JavaScript models rendering our kind of technology for us, because we're an e-commerce company. We're very content heavy, and so SEO is very important for us. Very important to what we reach our customers looking for our products as possible. And obviously, this counts for a lot of us, and probably everyone in the room can sympathize with this. We want something where it's just more fun to develop. You don't want to be burdened as a developer with complicated, not nice to use technology. So anything that could really fill these requirements was really what we were going for. So we had a choice. This was about years ago now, and we're looking at the space. Okay, so really the two biggest ones were Angular and React that we looked at, and we did some cost benefits. Right, there's some uncertainty with the migration from version 1 of Angular to version 2. We really weren't sure about the whole two-way data mining thing compared to unidirectional data flow. A lot of our web applications were such that we were already getting burned from reasoning about how state works. So in short, basically React's philosophy really fit what we wanted to do as a company and how we wanted to reason about it better. So basically, we went with React. And so we ended up with the following stack, basically. So we're obviously using Node, we're using React. When we started, it's worth calling out, there was no clear leader in terms of Flux implementations. So there's like Flux and Reflux and this and that and whatever. So we actually started with a vanilla Facebook. We followed the vanilla Flux implementation that Facebook had. We used that as a reference. So that when a clear leader emerged, we wouldn't be burned by already invested too much into one of them. So today we're using Redux, and we still have a few places where we're using vanilla Flux implementation. And we moved over to using Webpack for all of the bundle needs for our purposes. So really how do we get there? Like, how do we get from older, like an aging monolithic code base that has a lot of disparate technologies, a lot of disparate different forms of JavaScript modules, that's the reason I mentioned it. How do we get from that to this new shiny state? So really, we're doing it in 3 phases. And the first was getting small, isolated portions of the site into React and Flux. So we had a team of online applications. They rebuilt the Agile project application. That did it. It was right there. Over there. Thank you. But anyways, so we had, so in tandem with one team rebuilding this more or less standalone app, we also took on this project where we had, Charles going to talk about this a little bit more, where we started to needed to refactor, redesign our homepage and our navigation. That was a really good opportunity to figure out how can we actually get all the touch points to work, how do we get this integration working. The next step, and this is where we are today, is having universal React and Redux. Like how do we get a universal server-side rendered application, like Node app, that will actually handle all our rendering needs for us, and how do we integrate that back to our existing web application. So I'll talk about that a little bit later. And then the vision for us really going forward is to get everything towards this standalone Node service, so that really JavaScript is the thing that handles all of our front end. So Sean will talk a little bit about redesign.
So phase 1, we had this navigation homepage redesign project, and this was a good candidate for introducing React because it was fairly isolated. So, this top of our page, you can see here there's kind of this fly down. It's kind of fly down navigation that is entirely client-side rendered. So we could actually build a React app that renders this top of the page and then just inject it into a kind of Python app with a PHP app. So it's really only a few lines of code, right? We created an app that supports a bootstrap and a header component. And so bootstrap just fetches some of the data requirements for the nav links and images in the map. And then the header component is sort of a container for the entire thing. And all we do is just inject that into a a DOM element called header app, and that's pretty much it. So the problem was that we still needed to have a few more touch points that we poke a few more holes. And so this is a bad pattern, don't expose things I wanted, obviously, but this is for V1, this is kind of a quick and dirty approach. So our legacy page can still talk to our React app. For example, we had to when you clicked on a favorite, you had to update the favorites counter in the header. So this was kind of the lightweight approach we did, just to kind of prove React and make sure that it would actually work for us. The other thing we did was we created a reusable component library. And we try to think of components as really small, flexible building blocks. Also, they should be stateless whenever possible. And we even started building non-native versions of some of the form elements, just because we never wanted to mix kind of the DOM state with the state of the React app. So here's kind of an example of how components of these small building blocks. We might have a product component that is composed of smaller components, like there's an artwork that has the thumbnail, title, and an artist attribution that has the little avatar. And so these things can then be mixed and matched in other ways by other teams. They can sort of compose their own UI based on these little tiny bits. And then one of the things that was really important for us was being able to test our views. I know there's a lot of disagreement on the value of testing your view code, but we thought this is important because we have a lot of bugs in our UI layer. And one of the things we kind of kept running into was really fragile test assertions where we were kind of traversing a DOM and anytime you change your HTML structure, the piece would break. And so you might have heard this library at Airbnb called Enzyme, which gives these really nice kind of jQuery-like selectors, so your test is a lot easier to read and write. So for example here, we're testing the food component is rendering some bar elements inside of it.
So I'll talk about a little bit about where we are today and what we're working on. So as moving us towards our ultimate long-term vision, what we really wanted to do was to make the entire front end as much like a dumb view of the way React components are possible. So basically we would have an API that provides enough information that a front end, which really doesn't know anything about our business logic, it just will render whatever the API provides it. So that's what we're doing today. We've been doing it. We've redesigned our product description pages in a way that makes it very easy to launch new ones and launch new verticals and launch new products with different kinds of options that don't exist today. Because our front end really doesn't know anything about these concepts beyond what their abstract structure is. So React really facilitated reasoning about our entire application in this way, where we have our data, our state, and then we have our view. So our API is our state, and our view is basically our front end. So it is universal now. It is isomorphic. We have a standalone node service. I'll go a little bit into how the different pieces of our stack communicate with each other. We also did responsive layouts with React, and it's fairly easy to add in new projects that get different parts of the page. Existing web app either refactored into this or add entirely new features. So this is an example of our product description page. So what you'll see here is that again, we weren't in a position where we could refactor everything all at once in order to deliver value, but we still want to deliver this new, substantially better experience for our customers, where they can more easily find all the different options they're looking for in customers and products. And so what we have is actually a portion of the page is handled by our isomorphic renderer, universal renderer in Node, but we still have some window chromes and stuff that's in the process of being ported, but that's actually still handled by the Python app. So here we can look at an architecture diagram and we'll show you what that actually kind of looks like. So, the browser is Nginx, but the browser hits Nginx, and then that will route to our existing web stack, which is basically Python. We have some APIs as well. Now, there's this kind of roundabout business. You're like, hey, why is this weird round trip, right? Why does Python go to Node? And Node will have some data requirements because it makes some API calls, right? And so Unfortunately, that goes back to our stack, and we'll get the data that it needs. But this starts letting us already reason about our front end as we're in this with the node. We have node handling its front end, and there's this API there for external data requirements. So this kind of looks a little messy, right? So one of our DevOps engineers, actually, I think he pointed this out best. He says, what we have is a node app that gets requests from the web server so that it can make requests to the web server and deliver that back to the web server. Right? So it seems a little off, and it seems really crazy. But it's actually a really important part of us being able to transition incrementally. Because the cost of actually just going straight from Nginx to Node would mean we would have to refactor lots of stuff. It's actually not delivering any value to the customer. And that means that this is extra expense doing things that are not delivering value to customers and are really expensive. Actually, I guess I was a little earlier than that. So, of course, this is not a permanent state of things. We're actually migrating all these different lagging features out, and pretty soon we're going to get Nginx straight to Node. But having this really weird round trip was really crucial for us. Like, we compromised a little bit of round trip latency with the back and forth there, but it facilitated our ability to actually ship features and deliver value. So another aspect of the current phase that we're in with incorporating React into our stack is really consolidating all of our efforts to be responsive. And so React has actually made that very simple for us. So we've extended, we basically created these React breakpoint components, right? And so you have media queries, everyone knows about media queries, and those are great. They're great for determining how things are going to look in different breakpoints. But what media queries don't let you do is conditionally render different markup. And so if you're relying only on media queries, and you need to have all the markup for all the different device sizes that you're going to have, you're going to end up having a lot more markup than you're going to need for any given environment. And it ends up being substantially easier to actually have these breakpoint helpers. You can basically say, you can define what breakpoint different components are rendered in. And part of our strategy with our reusable component library is that every component defines what its behavior is at these various different breakpoints. So we have one definition of breakpoints, and we get media queries and conditional HTML rendering that come from these. It makes it just a very visual, declarative way to see what's going to happen in a particular environment. So Sean's going to talk a little bit about our challenges.
Yeah, so when we started down this path, we ran into a bunch of different things, and initially one of the hardest things was kind of like what library to use, right? We knew we kind of go on React after we did the React Angular analysis, but then when it came to like state management, there was I think half of it, or probably a dozen different Flux implementations, Reflux and Fluxor and Flumux and a whole bunch, and so that was really hard to kind of navigate that NPM land. And another thing that was difficult was around component versioning. So we created this Minted UI component library, but it was sort of versioned as a whole. So different teams wanted to pick and choose different components within that library at different versions. So this made upgrading across teams really hard. Everyone was kind of locked in at one version of the component library. So we're thinking about ways to kind of break that out. Version the individual components separately. And another thing to point out, if you're doing universal JavaScript and some kind of responsive, like the responsive breakpoints that Andy pointed out, you can run into an issue where your server render code does not match your client render code, mainly because the server doesn't know anything about the viewport, right? So it doesn't know how to render the different breakpoints. And so one way around that is you can do some device sniffing on the back end or have some defaults, but it's definitely something to watch out for. And also, we have this great API-driven front end now. However, we haven't really solved the data fetching problem. So we're kind of overfetching like the entire data needs of the application that it would ever need. And so really what we want to do is just fetch the initial state or little bits of state that the user is actually seeing. So there's lots of tools out there, Relay is an example. And so kind of some some recommendations and sort of where we're headed in the future. We definitely encourage using a few number of well-supported libraries. So, try to limit the number of dependencies you have, and especially favor libraries that have, their own set of dependencies that's small, just because you want to make sure your upgrade path is easier. And then most importantly, though, your core business logic should definitely not be tied to any framework. So if you do want to swap one of these things out, it's a lot easier too. And then I should point out that we did end up with PM2 as our node process manager. However, we encourage you to look at Strong Loop because it has a lot better kind of tooling and deployment and monitoring features.
So I'll talk about some of the other ones here. So Sean pointed out some of the pain points about having one repo that's versioned for all your different components. So the pain there really is like you're a team, you have something that you wrote a month ago, say, right? You want to get a new modal, for instance, that was just written in NetUI or whatever. And whoops, you can't actually incorporate it unless you now bump all your other components that you're using because all the versioning is done together. That becomes really painful because essentially that means that if you rapidly develop your component library, you're shifting technical debt onto other teams. And that gets really annoying really quickly. So a really great solution for this is to use what's called a mono-repo approach. Some of you are sure familiar with this, but basically what it is within your repo, you have a directory full of packages, and each of these packages are their own NPM package. They have their own package.json. This is actually how Babel and React handle their different dependencies. They're all mono repos, and then you can npm follow Babel, React, preset this, Babel, React, or Babel, preset this, that. Each of those live in the Babel repo, so you don't get the pain of having 5 million repos, one for each component. So there's a nice tool called Meetup that can handle that for you. So you might want to Google just mono repo for package versioning. This takes away a lot of the pain for having these kinds of deployment libraries. So highly encourage just doing a mono repo if you're stuck with a library. Another pain point here, so when we first started up our node service, we decided to go with Webpack to actually bundle our server-side code because we wanted to have the smallest compiled, most performant artifact actually living in production that would be handling all the different requests. And so one of the mistakes that we actually made early on was not separating the dev environment from the production environment. And so what happens is as you're writing more and more code here, the developer is actually having to wait for Webpack to compile your code on changes. So we actually recommend just taking the time and separating it out. So if you're doing server-side rendering, you get node mod, you get Babel node set up, so you get on-the-fly compilation for your devs, because you really don't care about that tiny electronic penalty. But then you don't have to wait for your app to recompile all the time. So definitely something to think about is what are the differences between production and dev there. And lastly, like server-side rendering is really important for our business, but it's not necessarily important for everyone. And so it does add some complexity, with respect to your infrastructure, your DevOps, adds complexity with the type handle. If you have a React markup mismatches, when you have responsive layouts. So it adds enough complexity that you should actually carefully consider whether you need it now and whether you might need it in the future. So if you see your future needing it, it's probably easier to start with it because it's going to be hard to transition after. But really not everyone needs it. If you have an application behind the login, it's really a web app and there's not search engine index content that you need, really consider with just doing it client side. It does make things considerably easier. So you don't have to go to the whole cargo calls, get everything, all the testing, get server-side rendering as really needed. So these are our biggest recommendations and takeaways. So if anyone has any questions, we'll be happy to answer. So thank you very much.
I was just wondering when you do server-side rendering, only for bots, or are there other instances where you use that?
So server-side rendering is actually handled for all our customers as well. So we don't do differentiation of traffic in determining whether to do server-side rendering. We just have features of our site that are deferred to the web app. The other benefit of cloud is time to like.
So you always do server-side and you don't do client-side?
Yeah, so the way it works is server-side just renders your initial markup. And then what happens is part of that initial markup, you still have the script tag for the client bundle, which gets downloaded. Once that gets downloaded and run, then your app rebootstraps over the initial markup that you have, which is server-side rendered. The way React's implementation works internally is that we diff those two. So we'll diff the stable down, you'll see like, oh, it's the same, and then there's no like flash of death, there's no point in the consumer, but customer usually use it. But yeah, so it's the app is client side handled, with the initial render, the initial markup.
How are you using API driven front-end development? What's the benefit?
So
question. Can you repeat the question?
So what's the benefit of doing API-driven front-end development? So it really makes it a lot easier to think about the views, right? The views are just these kind of stateless things. They just have some data needs, and that data gets passed down to the front end and displays it. So we kind of minimize a lot of the component, and having any logic in the components, right?
I think maybe talk a little bit also about like a concrete example. So like, for example, we have a product description page. We have different kinds of options that consumers can interact with. So like you have colors, you have shapes, you have formats, you have papers, you have things that we haven't built yet. We have options that don't exist in our system yet today. So in the way we were building things before, like a lot of these types were defined at the front end, which means that if you want to implement a new feature, like a new kind of option that didn't exist before, you would have a lot of work to do that's spread out throughout the stack, back end and front end. The world we have today is we can actually add new kinds of product options, and the definitions of those options are actually in the API. So the front end is just like, oh, it's an option. I don't really know what kind of an option. The API will tell me what kind of option it is. The API will tell me what kind of a thing it is, what its name is, and all that.
So there's data about the front end in the API response, right? Versus having a bunch of hard-coded data in the JavaScript code. All that data is passed down to the backend. So you do have some, there is some like blurriness about the separation between your data and front end, as we're talking about, but data about the view in the API response. But it makes it a lot easier to add new